Hello grade 12s, welcome to my channel, and let us have a look at this question. It was shared to me by one of my students. It was a paper written in the Northwest during term 1. Okay, so this is to help those who are writing their final exams in May, June, okay, to prepare, because these questions often pose a few challenges. Trust me, a parabola and some straight line or whatever combination will always bring problems, all right? Because this is the well-studied graph ever, the parabola, and it has multiple applications into other situations. So in a way, often the most difficult or challenging questions come out from here. Now let's read. Question 4, we are given a sketch below showing the graphs of f of x equals minus 2x squared plus 4x plus 6. Now looking at the coefficient of x squared, it's a negative number, meaning a is less than 0, and that means we expect a grumpy face parabola. Do we see that? Yes, we do. Now let's locate the position of the axis of symmetry. This is positive, the middle term, that first term is also negative. Sorry, positive and negative. Knowing the formula minus b over 2a, it says our axis of symmetry will have a positive x value, okay? And we can see that the y-intercept is 6 and it's 6 at point D. So this is a perfect sketch for our graph of f. Again, the label gives it all away. Then we're given g of x equals minus 4x plus 12. So that's a negative slope, first of all, and it will have a positive y-intercept at 12. So I can write here that at that point I've got 12, okay? And if I work out my x-intercept here, it's going to be 3. So that is a common x-intercept for both the parabola and the straight line graph. And by the way, they are giving us the x-intercepts of the parabola, okay? C is the turning point of f, okay, that's great. What is this? Same C is the point of intersection of f and g, as you can see there. So, okay, that's fine. Now, A, minus 1 and 0, it's an x-intercept. 3 and 0 at B are both x-intercepts of f, okay? And D is the y-intercept of f. Great. So we can see the sketches or they are both perfectly described by the given information. So there's no manga business there. So let's answer some questions. 4.1.1 says determine the equation of the axis of symmetry. So we know that x is equal to 3 minus 1 over 2. It's the average. Remember, the x-coordinate at the turning point is the average of the x-intercepts. So this gives us 1. Okay, so that's the answer. So 2 marks, we get a mark for that and that. Now there's other options. One could write x is equal to minus b over 2a, which is going to be minus into 4 divided by 2 into minus 2. That also means x is 1. So this is another option on how to solve this. Another student may decide to take the first derivative of x and equate to 0. When we take the first derivative, then we get minus 4x plus 4 is equal to 0. And therefore, x is equal to 1. So that's a grade 12 approach, applying differential calculus. So you've got options on how to go about this, guys. So you can use the graph as it is given with enough information, or you can use the algebraic technique because we have a full equation, or we can use yet another algebraic technique applying calculus. So either one of these ways will give you a mark. Okay, great. So if you did this, you get a mark for those two steps. Then if you did this, you get a mark for substitutions and the answer. So one of those techniques are your options. Alright, so let's move on before we waste too much time. 4.1.2 says write down the coordinates of the turning point of F. Okay, C is the turning point, and we saw that the axis of symmetry is 1. So when you substitute 1 into the equation, maybe we choose the simplest because C is the common point. So we put 1 in there, it's going to be minus 4 plus 12, which is 8. Or we substitute into the original equation, 2 into 1 is minus 2 into 1 squared is basically minus 2. 4 into 1 is going to be 4. So minus 2 plus 4 is 2. 2 plus 6 is 8. So that's great. So actually the mark is in determining that one. Okay, but the question said write down, so you get your mark even if you don't show how you calculated that. 4.1.3 says determine the equation of a tangent to F parallel to BC. So if we want the equation of a tangent, it has to be parallel to BC. So this is something that would be passing on our graph, stuff like that. Okay, manzami. Okay, ingekamosheki. This is something like that. So that's the tangent. Okay. So now the trick here is that we need to find the point of tangency. The point of tangency is going to be x is to y. So we need to find that. Okay. But what we know is that if two lines are parallel, what do we understand? We understand that essentially they have the same gradient. So we are being given the gradient indirectly. So now to start off 4.3, we know that, look, the gradient at the point of tangency of the line itself, the tangent, and the gradient of the curve, the parabola, is going to be the same. So we're going to have to apply calculus here and say the first derivative of x is going to be equal to the gradient of the straight line, which is going to be minus 4. Why do I know it's minus 4? Because I am told that this line is parallel to G, and the gradient of G is minus 4. Now let's do the actual differentiation. It's going to be minus 4x plus 4 is equal to minus 4. If I solve for x quickly, so what I'm going to do, I transpose the 4, it becomes minus 4, which is minus 8, divided by minus 4 gives me 2. So that means my x coordinate at the point of tangency is 2. Now let's find the corresponding y value. F of 2 is going to be minus 2 into 2 squared plus 4 into 2 plus 6. This is 4 by 2, it's minus 8. Okay, this is minus 8 plus 8, it goes away, so that leaves me 6. Okay, so we can say therefore the point of tangency is such that 2 is to 6. Okay, what is the story then? We can say then the tangent line is such that y minus y1 is equal to m. Let me use this equation for a change. It's interesting. So I'm substituting this point of tangency because that's where the line is passing through. Y minus 6, we know that the gradient is minus 4 into x minus 2. This implies that we've got y minus 6 is equal to minus 4x plus 8. Therefore, y is equal to minus 4x. Transpose 6 there, it gives us 14. That is the equation of the tangent. Okay. Great. So that's a nice question. Bit of work for a grade 12. Right. So first and foremost, that step is important. This is literally very important. And doing the actual differentiation there gives us 2 marks. And then we get an extra mark for actually finding that point of tangency, because these marks can be a bit of a nightmare. So we've got 3 marks already. And then substituting this point of tangency into a correct format of an equation and getting our final equation gives us the 5 marks. Okay, so that is important. Great, let's move on. What is the next question? Next question here is 4.1.4. This one says, determine the values of d for which minus 2x squared plus 4x plus 6, which is the parabola, is equal to minus 4x plus d. So we can literally see this is a line. This is any line, because what is being varied here is the y-intercept d. But this is literally any line with that gradient, meaning it's a line parallel to g, parallel to that tangent we were given. And let's look at this tangent. It becomes very important. So if we extend our tangent into the y-axis, we can see that the y-intercept is 14. Okay? So that is 14. Great. So we are looking for a line that will have 2 positive unequal roots. Basically, this is suggesting that if we draw any tangent line, or sorry, any line parallel to G and the tangent essentially, let's show it in this color. So if we draw this line along if we draw that line along G, can you see we've got 2 points of intersection with the parabola? It's that point and this point. And what are the roots there? The x coordinates at the points of intersection are both positive and they are unequal. Now if we draw this line again through this point, you will notice that this line will have a y-intercept of 6. And of course, we are suggesting that this line is also parallel to those 2 graphs there. So we see that if we extend the parabola down, this line is going to meet the parabola there. But here the x-intercept, or should we say the x-coordinate at the point of intersection is 0. So 0 is not positive or negative, so it's not going to work. Now let's try again and draw this line. So obviously the straight line is much nicer when you make it mobile. So there is another line with a y-intercept that is negative or even less than 6. Can you see there? The point of intersection with the parabola is going to be there, meaning the x-intercept is not necessarily the x-intercept, but the x-coordinate at the point of intersection is negative, and the other one is going to be positive. So can you see it's not that? So this thing seems to happen in between here. Because if our line is between this tangent, because at the tangent itself, we only touch once. So the x-coordinate at the point of intersection is once. But from G, there's two positive ones, and all the way approaching D. Because what we are varying is the y-intercept, meaning it's a vertical shift of our graph of G. So this means D has to be a value between 14 and 6 for this to happen, because anywhere in between there, we will see that that particular line will intersect the parabola twice, such that the x-coordinates at the points of intersections are both positive. Let's draw another one to convince you if you are not convinced. So can you see this line is parallel to the others? And can you see the point of contact there is positive? I mean the x-coordinate at the point of contact is positive, and the x-coordinate at the point of contact is also positive, and these are unequal. So this is a line that we accept as our solution. So to write the solution, we're going to write D must be less than 14 but greater than 6. So can you see certain answers, they assist you. So be very careful. How they ask these questions is usually how you should be answering the following other questions. I don't know, answers to certain questions become answers to the follow-up questions, or at least they become an aid in answering the following questions. So usually for this technique or this format or this notation, you get your 2 marks. Great. So that is what we want. Otherwise, all these other lines did not help. This one did not help, and that one did not help. But the line of G or this line, they are both the solution. So we could see that anything in between 6 and 14 in terms of the y-intercept for that gradient of -4 will cut the parabola twice, such that the x-coordinates at the points of intersection are positive. So that is a question on the nature of the roots. One can easily do the algebraic technique here. It works pretty well. All right. So one can just use algebra. So you can say minus 2x plus 4x plus 6 is equal to minus 4x plus d. Then we write this in standard format. 2x squared plus 8x plus 6 minus d is equal to 0. Right? Right, and then we do the discriminant here. Now, to handle this business, we know that 4 unequal roots. Right? 4 unequal roots. It is such that b squared minus 4ac must be greater than 0, which will imply that 8 squared minus 4 into minus 2, d becomes 6 minus d, must be greater than 0. This implies that 64 plus, this is 8, ne? 8 by 6 is what? Is it 56? Yeah, I think so. It's 48, my lord. My brain is not working, ne? It's 48. Plus, no, it's going to be minus 8d must be greater than 0. This implies that minus 8d is greater than, we add those two, 48 plus 64, it's 112. So therefore d here, sign will change. So 112 divided by 8 is 14. Can you see? This gives you only one answer. As you can see, you only get one answer. Now, to answer the next piece of information, you have to do a bit of a huge calculation. We can say here the roots, the actual roots, are such that we've got minus x. X is equal to minus b. So our equation is going to be minus 8 plus or minus. I'm going to move quick, guys. I'm not going to repeat this. And we could see here we've got 112 minus 8d here. So it's going to be 1, 1, 2 minus 8d. But we already know that d is less than 14. That is important. Meaning 8 by 14 is 112, right? So that means if d is less than 14, it simply means we will not surpass this number inside this bracket by a value too great so that we get a negative under the square root sign. So if then the values of d are negative, then it's even much better. Okay, so great. So this implies that we've got this root minus 8 plus the square root of 112 minus 8d, all divided by minus 4, or x is equal to minus 8 plus the square root of 112 minus 8d, all divided by minus 4. Now our task here is to find the root that will always give us a positive answer in these ones, for any value of d for that matter, but provided the value of d is less than 14. That's the most important. Now if you look at this one here, if you look at this one, let's say d is 12, right? So it's going to have minus 112 into, minus 8 into 12. So that's 16, right? Then the square root of 16 is 4, right? So minus 8 plus 4 gives us a negative number, right? Yebo. A negative number divided by another negative number gives us a positive answer. Okay, but now let's say d is minus 15, because that's a value less than 14. Let's say d is minus 15. So can you see the okay, square root of 112 minus 8 into minus 15. Let's just see. So now we get a 2 root 58. Ne? Then minus 8. That gives us a 7,23. Divide by a negative number. It gives us a negative. So this one is undecided. It can give you a negative answer. It can give you a positive answer. But if we look at this one, I wrote the wrong expression there. If you look at this one, because what comes out of here is positive anyway, but if it is dragging a negative, we're going to have a negative on the numerator divided by negative on the denominator. We can tell that x here is greater than 0. The other one gives us a value greater than 0 when it likes. It gives us a value less than 0 when it likes. So we're not going to focus on that. So we can say we appreciate that minus 8 minus the square root of 112 minus 8d all over minus 4 is greater than 0. Because we said the roots must be positive. So for a positive root, this expression gives us positive values. Anyhow, let's keep going, guys. This is 0 over 1, then you cross multiply. So what do we get? We get minus 8 minus the square root of 112 minus 8d Is it greater than? No. We multiplied by negative across, so it becomes a negative, so it's less than 0 now. The sign changes, so minus the square root of 112 minus 8d is less than 8. Now radicals, you do as you know how. So this is going to be 112 minus 8d is less than 64. Then minus 8d is less than minus, let's see, 64 minus 112, it's minus 48. Therefore d is going to be greater than 6. Okay, so can you see we're getting a lot of work in different techniques. So we can write our conclusion and say therefore d must be less than 14 from above. So you have to drag that answer and then say it also has to be greater than 6. So you do get your answers, but sometimes in a very silly way. Obviously this is not a calculation you have to show on your script. This is what you do as a side calculation, because what matters here is this answer. The rest of the gymnastics is totally your own choice. So you can see using the graph in this instance is much easier than doing the algebraic calculation. But it's up to you, honestly, how you want to look at it. I just wanted to show you so that you don't give up in case you wanted to approach it this way. All right. Obviously, if you only get d is less than 14 and you stop there, you will get 1 mark, okay, and lose the other mark. Let's do the last question. This is question 4.2, okay. It says now determine the equation of a quadratic function with the following properties. The function is symmetrical to y equals a x squared minus 7x plus c about the y-axis. So once you hear something that is symmetrical about the axis, that is a reflection, okay? That is a reflection. Now, a reflection about the y-axis is what we call a horizontal reflection, okay? Now, a horizontal reflection says the x terms or the x values are multiplied by negative. Now, if we are looking at this function here, and we are told this function is symmetrical to the function in question, we can say h, let's just say this is h of x, is going to be, the first term is going to be the same, ax squared. But what changes is this middle term, because we said we multiply the x terms by a negative. So here we do the same and we get that. So the y-intercept is going to be the same. Remember, when you reflect the graphs, only x values. When you reflect the graph horizontally, only the x values change, but the y values remain the same. That's why c won't change. Again, the characteristics of the graphs are not going to change, meaning whatever a value it was, it has to remain that value. If it was positive, it remains positive. And it remains at that same value, because the only thing is just the somersaulting of the graph. But it's not a vertical reflection that changes this shape of the graph. The graph's shape doesn't change, but it's just the position in the axis that is going to change as a result of the somersaulting. So that is the most important part. So the reason they are giving us this equation is so that we can work out the probable equation for this line h of x, okay? Because that is how you would reflect this. But sometimes this may be a lie, but I'll try and prove it later. Let's just try and solve for now. Then we're told the function has the axis of symmetry with the equation x is equal to minus 1. Now we know that also, what do we know? We know that actually, we know that 2a, no, The axis of symmetry is minus b over 2a is equal to 1. This implies that we've got minus into 7 divided by 2 into a is equal to 1 over 1. Then we cross multiply. So maths, guys, the basics must always be solid. So we've got 2a is equal to minus 7. Therefore, our a is going to be minus 7 over 2. Then you see, we found the value for a. Great. This implies, maybe let's do this one. We can say then, our h of x is equal to minus 7 over 2 x squared plus 7x plus c. Then what are we told here? The function has a value of minus 20 when x is 4. So literally this is suggesting that at this point we've got minus 20. So we can substitute this into the equation. Minus 20 is equal to minus 7 over 2. Where we see x, we put that plus c. And this implies that minus 20 is, so this is going to be basically 16. So this is minus 7 times 8. So it gives us minus 56 plus 28 plus c. Therefore, our c is going to be it's going to be 8. Yeah. So therefore, h of x is equal to minus 7 over 2 x squared plus 7x plus 8. So that's the equation of our function. Yo, I'm telling you. Perhaps here we can say let the function be h, okay, such that this is the statement that should actually be here. Sometimes when you explain your task, guys, life becomes easy. So you let the function be h such that this h of x, that changes the sign of the middle term when this is a horizontal reflection. And then we use all the properties that we were given. Okay, so that's it. That's it, guys. That's it. How many marks? 6. Great. So first of all, you get a mark for knowing what is the hypothetical expression according to the given information, and essentially finding the a value. It's another mark. Right. And essentially substituting this point and essentially finding the equation. So I don't know why they're giving 6 marks. Why? 1, 2, 3, 4. Okay, ngathi ufuna ungiqhela. Ndiyazi le 6 marks bayithatha phi. Ifuna ukundixaka. 1, 2, 3, 4. Let it be found by 4 marks nje. Hayi nani ngiyahlupha bafethu kanimeni kancinci. Yo. Sizothatha phi ke mna ezi marks? Ndizawuzithatha phi? Angeke. Mhlawumbe ke this expression is a mark. 1, 2, 3, 4, 5. Eyokugqibela izawuvela phi ke ngoku? Siyithatha phi eyokugqibela? Hayi maske sithi ngula 8. Mhlawumbe. Anyway, that is how you get the 6 marks, guys. I hope you enjoyed the video. Otherwise, maths is always maths, guys. It does wonders to you. So let's leave it for now. I'll see you guys another time. Goodbye.